Okay, starting section 8.1 here, the first thing we need to do is remind ourselves what a Riemann sum is. Remember here that we have our function times some small change in the input, delta t. Then we evaluate us at a second coordinate, t2, times some change in the input. And all the way up to f of t sub n times some change in the input. That's a Riemann sum. And we know that whether we do right or left hand sums, when we take the limit of our Riemann sum, and as we let n go to infinity, we get our integral. Okay, it's very important to note that during section 8.1 and for the rest of chapter 8 altogether. So let's go to example 1. Here's example 1 in section 8.1, and what we're looking at is we're going to find the area of this triangle using calculus. I mean, we know what the area is. So the area equals 1/2 base times height, 10 times 5, which equals what, 25? Okay, so now let's try this using some calculus stuff and see if we can get the same thing. Okay, so what we're going to look at is little strips here, little rectangular strips. Okay, where the width of our strip is going to be a little delta H. Okay, and the width here, let's call this for one, let's call it W naught. The length here is W naught, and the width of it is delta H. Okay, so we're going to use, well, let's just say the area of one of those strips. Let's say area of strip equals W naught times delta H. Now the problem here is we need to get W naught in terms of delta H. So to do that, we're going to use similar triangles. And again, similar triangles will be used throughout chapter 8. So make sure we get comfortable with similar triangles. And how we're going to do it is, we're going to say the height up to the center of this thing here, if the total height is, what's the total height? 5. So this is going to be 5 minus some H naught. What remains? So that is, let's say this height here is H naught. Okay. So if we look at similar triangles, we can get what? W naught over this, W naught over 10 equals 5 minus H naught over the total height, which is what, 5? Okay, and so now multiplying both sides by 10, we get the W naught equals 5 goes in 10 2 times, so it leaves us with 10 minus 2 H naught. Okay, so now we get that the area of our slice equals 10 minus 2 H naught times delta H. Okay, so now what you got to think of is we're going to do that for every H naught. For H naught, H1, so that is we're going to have the area of this triangle is going to be, you would do it, for example, you would do it here, and you'd go right up above it and do one, then right up above it and do one, and you add all those up. So we got 10 minus 2 H naught times delta H plus 10 minus 2 H1 times delta H plus 10 minus 2 h2 delta h, and plus dot 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 10 minus 2 hn delta h. Okay, if we look back at our Riemann sums, we see that is a Riemann sum, and so we would let the limit as n goes to infinity, and we would have the integral. The integral from what? We're integrating with respect to h, and h is going to run from 0 to 5 of 10 minus 2 times h, and when we let the delta h becomes dh, when we take the limit as n goes to infinity and that delta h goes to 0, we call it dh. Okay, now let's integrate this. We get 10h minus h squared from 0 to 5, which equals what, 50 minus 25, which equals 25. And so we see that we got it to match up here with this number using calculus. Okay, that's going to conclude this video on the first example in section 8.1. Thank you.